All right, so there was a question asked about how is it that you mathematically prove continuity at a point. So in order to do that, what you have to do is 3 steps. Okay, so prove continuity at a point C. We need to show, step 1, that f of c exists. So in other words, you're going to put in the value of c into your function and then find the answer if it exists. If it doesn't exist, then obviously there's no continuity there. If it does exist, then write the answer. Step 2, show that the limit of f of x as x approaches c exists as well. If it doesn't exist, again, there is no continuity. If it does exist, then write the answer. Then once you have the answers for 1 and 2, then step 3 says, do those 2 answers equal to each other? And if they do, then you have continuity at the point. If you don't, then there is no continuity at that point. So let me give you 2 different examples. So example 1, what I'm going to do is I'm going to prove or disprove continuity at a point for a function, let's say f of x equal to x squared plus 5. And we're going to say at... let me write at x equal to 2. So there's my point value. Okay, so at x equal to 2. So step 1, is it true that f of 2 exists? Well, f of 2 is 2 squared plus 5, which is 4, plus 5, which is 9. So yes, it is true that f of 2 exists, and my answer is 9. Now, second, what is the limit as x approaches 2 of x squared plus 5? Well, in order to do this, all we have to do is use direct substitution for this limit. So that's 2 squared plus 5. So that's 4 plus 5. So that equals 9. Notice how part 1 and part 2 are equal to each other. So step 3, is it true that the limit as x approaches 2 of f of x is equal to f of 2? Okay, is it true that the values for 1 and 2 are equal? So yeah, we found out that 9 was equal to 9. So that checks out. So if this all comes out to be true, then we can say that f of x is continuous at x equal to 2. And that's my answer for this one. Now, let me show you one that's discontinuous at a point. So example number 2. So for example number 2, I'm going to use a piecewise function here. Let's say, we'll say, I don't know, let me try to think of one here. Maybe we'll do like a 1 as x is greater than 1 and a negative 1 as x is less than or equal to 1. So let me graph this really quick just so we can see a visual representation of this kind of. So we're going to have some tick marks here. Let me just put this up here for us because this is going to be useful when we try to find the limit. All right, so the graph is going to look something like this. It's going to be a positive 1, okay, as long as it's going towards the right side, and then it's going to be a negative 1, but you're going to have to color that part in right here. So step number 1. I forgot to actually write where, right? So we're going to say at x equals 0. Sorry about that. But we're going to say, is this function continuous at x equal to 0? So there's my graph, there's my function, my piecewise function. Okay? So does f of 0 exist? So if I look at the graph, f of 0 is right here, right, where I highlighted it. So it does exist. The answer for it would be negative 1. 2. What is the limit as x approaches 0 for this function? Well, if I look at the limit, as it approaches 0 from the left-hand side, the answer would be a -1. And as it approaches 0 from the right-hand side, the answer would be a +1. So this would be its limit there and there. So notice this limit does not exist. Okay? So, 3. Is it true that the limit as x approaches 0 of f of x is the same as f of 0? And that would be a big no, right? Because -1 is not equal to does not exist. So then you'd say f of x is not continuous. Let me rewrite that. Continuous at x equal to 0. So this is how you figure out continuity at a point. Hopefully this helps. Let me see. Yeah, I did that already. Hopefully this helps. If not, just let me know.